Today we're looking at operations of radicals, day 2. So this is chapter 6, topic 6, day 2. We're going to be looking at how to add and subtract radicals. Okay, so if we look at number 6, so in order to add or subtract radicals, we have to have the same index and the same radicand. Okay, so if we look at number 6, we got the square root of 98 minus 2 times square root of 32. All right, so they have the same index. They're both square roots, but they have different radicands. We got 98 and we got 32. So what we're going to have to do is we're going to have to simplify those two radicals to see if we can make them smaller and make them into the same radicand. So if we simplify square root of 98, we got 2 times 49. And 49 becomes 7 times 7. So square root of 98 can be written as 2 times 7 times 7. And then we got minus 2 times square root of 32, so we can break down 32 into 2 times 16. And 16 breaks down into 2 times 8. 8 breaks into 2 times 4. And 4 breaks into 2 times 2. So it breaks down into 5 2's. So we got the square root of 2 times 2 times 2 times 2 times 2. All right, now that we've got them expanded, we can start taking stuff out of the radical. So in the first one, the first radical, we got 2 7's that can come out of the radical, and that's it. So 7 comes out, square root of 2 stays under. And then minus 2 times, and then under this radical, we can take out a pair of 2's, and we can take out another pair of 2's. And we already have the 2 on the outside. And then what we have left is just the square root of 2. We can put it back together. So this is 7 square root of 2 minus 2 times 2 times 2, which is 8. So 8 square root of 2. Okay, now we've put them into such a way that they have the same radicand. Okay, they both have square root of 2. So our answer is going to be a square root of 2 answer. To find the coefficient, we just have to subtract the coefficients here, 7 minus 8. 7 minus 8. Because we have 7 square roots of 2, we're taking away 8 square roots of 2, so we'll be left with negative 1 square roots of 2, or just negative square root of 2. So our answer number 6 would be negative square root of 2. That would be this subtracted. Number 7, we have 4 square root of 8 plus 3 square root of 50. So the first thing we want to do is split up the radicands. So 4 times, so 8 splits up into 2 times 4, and 4 splits up into 2 times 2. So this is the square root of 2 times 2 times 2 plus 3 times square root. We got to split up 50. So 50 breaks up into 2 times 25, and 25 breaks up into 5 times 5. So this is 5 times 5 times 2. Okay, so now we can start taking stuff out. So the 4 is still on the outside here. We got 2 2's, so I can bring a 2 out. And then that's all that I can bring out. I still have a square root of 2 that's underneath the radical. Plus 3 times, so under the radical I have 2 5's, so I can bring the 2 5's out to make a 5 on the outside, so 3 times 5. And then I don't have anything else I can bring out, so all I have left under the radical is 2. So I can put this back together. 4 times 2 is 8, so this is 8 square root of 2. plus 3 times 5, which is 15. So this is 15 square root of 2. So my answer, all right, so I have square root of 2 and square root of 2. So my answer is going to be some sort of square root of 2. To find the number in front, I just have to combine the 8 plus 15. So 8 plus 15 is 23. So my answer is 23 square root of 2, or 23 times the square root of 2. All right, and then we're going to look at just a real quick modeling problem, okay, because there is a question in the homework like this modeling problem. It says a formula that the police used for finding the speed, S, in miles per hour that a car was going from the length L in feet of its skid marks is S equals square root of 5L. Okay, so this is the formula we'll be using. S measures the speed of the car, L measures the length of the skid mark, and this is the relationship between the two. The Guinness Book of World Records reports that in 1960, a Jaguar in England had the longest skid mark ever recorded, 950 feet. What was the Jaguar's approximate speed? Okay, so essentially we need to set up our formula, except the 950 is going to replace the length in the formula. So our formula is speed equals the square root of 5 times the length of the skid mark. But the length of the skid mark for this problem is 950. All right, so I can multiply that 5 and that 950 together. So let me pull out my calculator. Where is it? I don't have it. So 5 times 950 is 4750. So this becomes 4750. So the speed is equal to the square root of 4750. Now I can actually calculate that in my calculator by taking the square root of 4750. So I'm going to hit the square root button, and I get 68.9. I'll go ahead and round that to 69 just for fun. So this will be 69 miles per hour. So if the skid mark of the car was 950 feet, then the formula says that the speed must be 69 miles per hour. Now they also ask how far a car will travel if it skids from 50 miles per hour to a stop. Okay, so this one they're giving us the speed. Okay, so we have a formula, but this one they're giving us the speed instead of the length. So I'm going to replace the speed with 50 miles per hour. So the formula becomes 50 equals the square root of 5 times the length. Okay, so this is a little bit different because this time I have to solve this equation for the length. Okay, so I have to solve this radical equation. So I have to get rid of the square root symbol and I have to get rid of the 5. Okay, so first I'm going to get rid of the square root symbol by squaring both sides because a square gets rid of a square root. So that just leaves me with 5L on the left side, and then, the right side. The left side becomes 50 squared, which is 2,500. All right, and then now I can solve this equation for L by dividing by 5. So the length L will be equal to 2,500 divided by 5, which is 500. So 500 feet is the length of the skid mark. All right, thank you very much.